Hello, and welcome to today's lesson. We're in our Circles and Polygons Unit 1, Lesson 5. Our goal for this lesson is to determine the missing angles on a kite, to determine angles and segment lengths formed by the diagonals of a kite, name the parts of a trapezoid, determine missing angles on a trapezoid, and then finally understand the relationship between the diagonals of a trapezoid. So just for a quick reminder, looking back at what a kite is, okay, when we have a kite, we have two distinct pairs of congruent sides. Okay, so making sure that we have the equal lengths on the consecutive sides, and that's important to make sure that they are consecutive and connected. Some other terms that we have our vertex angles, and then we have our non-vertex angles. And we'll see as we work through, the non-vertex angles are actually connected to each other in measurement. The vertex angles are not. Okay, a kite does have one line of reflectional symmetry. This line is important because if we have a line of symmetry, that's where we can fold and match up pieces. We can start to see that angles are congruent, and we can work through some of our progression with angles and triangles at that point. So now, looking at the kite angles conjecture. Okay, and that's what we talked about on that last page. The non-vertex angles of a kite are congruent. And this does work for all kites overall. So now we can use that idea to solve for problems. If we think back earlier in the unit, we know that a kite is a four-sided shape, and all four-sided shapes have internal angle sums of 360 degrees. So when we're looking at this, we know that the two non-vertex angles are equal to each other, so we can copy over the variable x into that position, and then we can work with a summation and solve for x. So 2x plus 100 plus 70 equals 360. Then we have 2x plus 170 equals 360. And then we can finish our algebra here quickly, subtracting 170 and dividing by 2. So we've got 360 minus 170 gives us a total of 190. Divide that into the two non-vertex angles, and we get a total of 95 for each. So we have 95 degrees for the upper angle, 95 degrees for the lower angle. We can see based on the picture those angle measures make sense because the angle does look to be bigger than 90 degrees. Now, always remember when you get an answer, you can work your way back, add up the four angles, make sure that you get 360 for a total. Now, one of the most common mistakes students make is they try to make these two angles equal to each other. So they make the two vertex angles equal, and that's not the case. It's only the non-vertex angles, the angles in between the two non-congruent side lengths, that are equal to each other. So we can fill in the upper non-vertex with a 100, and then we use our basic rules of four-sided shapes to solve for the missing angle. So x plus 100 plus 100 plus 65 equals 360. Okay, and then we can work through, simplify, and solve from there. X plus 265 equals 360. Subtract 265 from both sides, and we get x equals 95. Okay, now, these happen to be the same answer. Okay, it's just based on the numbers that we used here. It's not something where it will always be 95 for a total. Now, our next conjecture that we have is the kite diagonals conjecture. And what that states is, I just dropped my marker there for a second. The diagonals of a kite are perpendicular to each other. So the diagonals connect the two non-vertex angles and the two vertex angles. And if this is a kite, it does make a 90-degree angle since they are perpendicular. And we can use that and the ideas that we know about triangles to solve for missing angles in a picture. So if we're working with a triangle, we know that all of these inner angles created by the two diagonals are 90s. And then we can use our rules for a three-sided shape, okay, knowing that the sum of all interior angles n minus 2 times 180. So for a triangle, we get a sum of 180, and we can use that to solve for x. So x plus 30 plus 90 equals 180. X plus 120 equals 180, and we end up with x equals 60. Okay, we can also use that to work our way through and solve some other missing pieces. And once we have that, we've got the 30, we've got the 60, we have the 90, and then we can work our way through to find some of the other missing pieces. Okay, and then also understand the similarity that comes with having a line of symmetry. So when we have a line of symmetry, we can fold the kite along that line, and we can see that the 30 and the y are going to match up with each other. We can see that the 70 and the z line up with each other, and then we could find any other missing angles as well. But the line of symmetry is an important piece, along with the fact that the perpendiculars are 90 degrees for each angle. Okay, next conjecture we have, the kite diagonals bisector conjecture. Okay, the diagonal connecting the vertex angles of the kite is the perpendicular bisector of the other diagonal. So we know that now we're cutting this diagonal in half. That makes sense based on the concept of the line of symmetry. Okay, so we're really bringing a lot of these concepts together, seeing why these conjectures work, and symmetry is an important part to understand that it is a bisector, and more importantly, a perpendicular bisector. The next conjecture we have is the kite angle bisector conjecture. The vertex angles of a kite are bisected by a diagonal. So we want to understand that, once again, we're working with the vertex angles, okay, not the non-vertex angles, and using the idea again of the line of symmetry. If we're folding something in half, it makes sense that the angle measures on either side of that fold are congruent to each other. Once we have those ideas put into place, we can use those ideas to help us solve for missing angles. Once again, using the idea of a triangle, knowing that x equals 90, we have a kite, we have the diagonals, so they have to be perpendicular to each other, and then working through to find any missing pieces. So first we would want to solve for w, because we have the other two angle measures. We know that this is a 90, and once we have w, we can really fill out the rest of the missing pieces. So we have w plus 66 plus 90 equals 180. And then we just want to go through and finish up by subtracting the two angles from 180. Minus 66 minus 90. and that helps us find our missing angle of 24. Once we have the missing angle of 24, we can use the bisector conjecture to be able to go through and solve for z. So we have that fold and it matches up. We can solve for y, which is a 52. And if we want, we could transfer down the 66. We could transfer up the 38. And we have all of the missing angles of this kite taken care of. Okay, looking at our next shape, we're going to be looking at the trapezoid. Okay, talking about the names and pieces of a trapezoid. A trapezoid is made up of two parallel sides. The parallel sides are called the bases. Okay, and then we have base angles both at the top, and we don't know if these angles are equal. It might look like they're equal in this picture, but we'll have to try to prove that they're equal based on some other factors. And then we've got the base angles at the bottom. So we have a pair of upper base angles and a pair of lower base angles. But the important part about a trapezoid, only one pair of parallel sides. So from this, we can get our trapezoid consecutive angles conjecture. The consecutive angles between the bases of a trapezoid are supplementary. Now, why is this true? This goes back to our idea of parallel lines intersected by a transversal. And whenever we have a transversal intersecting parallel lines, there are only two possible angle measures in this entire picture. And we can see based on vertical angles that we would have to have B in both places, A in both places, and then we can look at corresponding angles, alternate interior angles, and we can see that every angle in this picture is either a B or an A. And if we look over at the other side, we have to use different letters here because we don't know right now if these angles are congruent to anything else. Once again, always looking for vertical angles first. Those are the easiest to fill in. And then based on the parallel lines, we have corresponding angles and linear pairs. So we can see in this entire picture, there are only four possible angles created from the trapezoid based on the fact that we have parallel lines. So now that makes our work a little bit easier once we get to this picture. If you want, turn it into a parallel intersected by transversal picture. Then it's easy to see that we can copy the 75 into that upper angle. Then we have a linear pair, which is going to add up to 180. And we can use that to solve for x. If we transfer over to the other side, once again, we've got parallel lines cut by a transversal. The 65 can be copied into the corresponding upper angle. And then we've got our linear pair, which would help us solve for y, using the idea that the two angles 65 plus 115 is equal to 180. Same thing here on the other side. Okay, a couple last things here to wrap up our lesson, talking about the isosceles trapezoid conjecture. Okay, the base angles of an isosceles trapezoid are congruent. We know that they're an isosceles trapezoid because of the tick marks on the two sides. And based on those tick marks, we know that the lengths are the same, connecting parallel lines, so that creates base angles that have to be the same, just like we have with an isosceles triangle. Okay, using that idea, we can fill in this picture, knowing that, once again, looking for the equal measurements on the sides. That allows us to copy over the angle measures from there. Okay, and that completes today's lesson. Okay, we've got lesson 5 homework in Schoology. Good luck, and let me know if you have any questions.